Hey guys. All right. Just moving along with the quadratics unit here. Third lesson is called completing the square. Okay, so what we did in our first lesson was learning about the vertex form of a quadratic function or of a parabola. Unit 2 was what the standard form is and how to go from vertex to the standard form. And now for completing the square is almost kind of the reverse process. Okay, if we have an equation in standard form of a quadratic function, how do we work backwards and make that into vertex form? Okay, so the process we do that is called completing the square. All right, so just a bit of review here. Determine the equation of the quadratic function in vertex form and in standard form. Okay, so here we have 5, 9. Here's our PQ. We're going to do vertex form first. And then it's 1, 5, and this can be our x, y. Okay, it's passing through. So for step 1, we're going to do it in vertex form first. Y equals a, x minus p squared plus q. Okay, so we're going to plug in everything we know. Y is 5. We do not know a yet. X is 1. Our p is also 5 squared plus 9. So I'm going to go minus 9, negative 4 equals a. 1 minus 5 is negative 4, squared is 16. I'll divide by 16. And negative 4 over 16 is the same thing as negative 1/4. So our equation is going to be y equals negative 1/4 x minus 5 squared plus 9. Okay, so here's our equation in vertex form. So now we want to figure out what's this guy going to look like in standard form. Okay, so for standard form, we're going to start in vertex form. And I'm going to convert this into standard form. So this is y equals negative 1/4 x minus 5, x minus 5 plus 9. Y equals negative 1/4 x squared minus 5x minus 5x. I'm just foiling or distributing this one out over here. Plus 25 plus 9. So I got y equals negative 1/4 x squared. Negative 1/4 times negative 5 is 5/4 x plus 5/4 x minus 25 over 4 plus 9. Bit of fractions over here, but that's all right. So we got y equals negative 1/4 x squared. 5/4 plus 5/4 is 10/4. We'll simplify that in a second. And if I want to add this and this, I need to get a common denominator. So I'm going to make this 9 over 1. I'm going to multiply times 4 minus 25 over 4 plus 36 over 4. Y equals negative 1/4 x squared. 10 over 4 is the same thing as 5 over 2 x. Negative 25 over 4 plus 36 over 4 is 11 over 4. All right, so definitely a trickier question over here, but this is kind of the process that we do for going from vertex form. So we're going from vertex form starting here, and we're ending in standard form down over here. Now the rest of the lesson is going to be like, well, how do we do it in reverse order? What if we gave you this, and we're asking you for this guy over here in vertex form? Okay. All right. So we're talking about what I mean by a perfect square trinomial over here. Okay. Suppose, I'm just going to do this off the side of here. Suppose I had to do x plus 7 squared. Okay, well, first of all, this is a perfect square because x plus 7 squared, if I'm squaring it, that means it's going to be a perfect square. Okay, so the same thing that if I go 4 squared is 16, well, 16 is a perfect square. If I go 5 squared is 25, 25 is a perfect square. If I go x plus 7 squared, which is x plus 7, which is x squared plus 7x plus 7x plus 49. that means x squared plus 14x plus 49 is going to be what we call a perfect square trinomial. Okay, so just looking back over here, we have a few kind of just talk about how this works in reverse over here. First of all, we need to be aware that 49 is we're getting from 7 squared. So 7 times 7 is 49. Where are we getting this number 14 from? Well, it was x times 7 and x times 7. 7 plus 7 is 14. So what we want to do over here, if we look at this number, 14, half of 14 is 7, and 7 squared is 49. Okay, so that's how we can get this. Now, what we're saying over here, first of all, x squared plus 4x by itself is not a perfect square trinomial. Okay, but I want to figure out what number do I need to put here in order for this to be a perfect square trinomial. Okay, following the pattern, half of 4 is 2. 2 squared is 4. Okay. And so when we do that, is this the same thing as x plus 2 squared, which is x plus 2, which is x squared plus 2x plus 2x plus 4, which is x squared plus 4x plus 4, right? Half of 4 is 2, 2 squared is 4. So back to this guy, okay? So what we're looking at is negative 12. Half of negative 12 is negative 6. Negative 6 squared equals 36. So we're going to put in a 36 in here to make this guy a perfect square trinomial. Okay, so complete the square. Convert from standard to vertex form. Okay, so we need to do this by completing the square over here. All right, so what I did in the last example is what I want to do is what do I need to add here in order to make this a perfect square trinomial? Because I want to get this guy into, I want to factor this into x minus p squared somehow, okay? So what we're going to do is how do we determine this number? Well, we look at this number. We have a 6. Half of 6 is 3. 3 squared is 9. Okay, so if I had a 9 here, I now have a perfect square trinomial. Now the thing is, I'm not allowed to add a 9 if there's not a 9 here to begin with. So what I'm going to do is if I add a 9, I'm going to subtract a 9 as well. Okay, so if I go 9 minus 9, well, this 9 minus 9 is really just 0. Okay, so the reason is, like, if I'm adding 0, well, it's not really changing anything. Okay, it could be add 0, you haven't changed it. But what I'm going to do is I'm just going to well, this guy is now a perfect square trinomial. Okay, and this guy factors 2 is always going to be x. And then what's half the middle number? Half the middle number is 3. It's going to be x plus 3 squared. We still have the minus 9 right over here. Okay, so this is how we complete the square. So now here's our answer in vertex form, sorry, in standard form, and this is the answer in vertex form. I'm just going to quickly confirm on my calculator here. But if I have y equals x squared plus 6x, I get this quadratic function over here. If I have y equals x plus 3 squared minus 9, the blue graph and the green graph are directly over top of each other. Okay, so that means that these guys are the same. Okay, and so again we got this answer by completing the square to get down to this one over here. All right, I hope that makes sense. Let's practice it a bit more. All right, so the rest of the lesson, guys, we're just going to go through a series of practice examples for you, and we're going to do this. Now, in this case, I have this extra plus 6 over here. So first thing is I'm going to go x squared minus 10x plus blank. And I'm still going to put a bit of a space here, but I'm still going to put this extra plus 6 over here, okay? So what I want to do here is I want to complete the square. Half of negative 10 is negative 5. So half of negative 10 is negative 5, and then negative 5 squared equals 25. So we want to put a 25 right here. Okay, so I can't just add a 25 whenever I want. That means I need to subtract a 25 here as well. Okay, so 25 minus 25 is 0, so that's why this equation is equivalent to this equation over here. It's like I've added 0, which is the same thing as not adding anything. Okay, so now it's like I want to just kind of group these guys together, and I'm going to factor this. Okay, now it's always going to be, well, what's half of negative 10? It's negative 5. So this guy becomes y equals x minus 5 squared. And now I still have this part over here. Negative 25 plus 6 is negative 19. Okay, so here's my answer in vertex form. X minus 5 squared minus 19. Okay, so a little bit harder here, and it's going to be harder because we're going to have to deal with a bit of fractions. And guys, I know fractions are a pain to deal with, but we just need to kind of get good at doing this as well. So here, half, let's back up, sorry. I want to go y equals x squared minus 5x plus something, and I still have this plus 1 here. Okay, so now it's half of negative 5 is negative 5 over 2. Okay, guys, we prefer to use fractions as opposed to decimals in this unit here. Okay, and now negative 5 over 2 squared, negative 5 squared is 25, 2 squared is 4. So we want to include 25 over 4. Okay, now if I added a 25 over 4, I need to subtract 25 over 4 like this. Okay, so now this is what we factor together, and it's always going to be half of negative 5 is negative 5 over 2. It's going to be y equals x minus 5 over 2 squared. This is this part factored. Now it's negative 25 over 4 plus 1. Negative 25 over 4 plus 1 is negative 25 over 4 plus 4 over 4, which is negative 21 over 4 minus 21 over 4. All right, so here's an example of how we've taken it from standard form, and we've converted it into vertex form. Get a little bit harder with the fractions over here, but really the same process. Okay, example 6. Now why is example 6 different? Obviously the numbers are different, but more specifically is we have a leading coefficient of 2 in this case. Okay, now what we're trying to get to is we're trying to get to this guy, a x minus p squared plus q. Now the reason why I wrote this is that this a is factored out of this guy over here. So here's what we're going to do. I'm going to just highlight, underline the first 2 terms. I'm not going to underline this guy. What I want to do is I want to factor out the 2 from this term and this term. Not this term, just the first 2. So it's going to be y equals 2 x squared minus 10x. Okay. So it's starting to look more like this because the 2 is the a value has been factored out. Now what I want to do is I want to complete the square here. Complete the square. So we got y equals 2. Now that's going to be x squared. Half of negative 10 is negative 5. Negative 5 squared is 25. Okay. Now here's the other thing where it's a little bit tricky. Normally I'd be subtracting 25, but really what I have here, if I had a 25 inside the brackets, 2 times 25 is equal to 50. Okay, so although it looks like I added a 25 that wasn't there before, I really added 50. So I need to subtract 50 right here. So this is going to be y equals 2 x minus 5 squared, because half negative 10 is negative 5. Negative 50 plus 15 is negative 35. Okay, so this is how this guy is converted into vertex form. All right, last one. We're going to convert from standard form into vertex form. So the same strategy over here is I'm just going to highlight the first 2 terms because I'm trying to get to this form. Okay, so it's like I'm highlighting under here. I'm going to factor out the negative 3 from the negative 3x squared and the negative 12x. So we can get y equals negative 3 x squared plus 4x minus 8. Okay. Now I want to complete the square here. Half of 4 is 2. 2 squared is 4. So we get y equals negative 3, x squared plus 4x plus 4. Again, middle term is 4, half of 4 is 2, 2 squared is 4, that's this part here. Okay, so I added a 4, but I really added negative 3 times 4, which is negative 12. So I added a negative 12 that wasn't there before. So if I want this to balance, I'm not going to subtract anything, I'm actually going to add. Since I added a negative 12, I'm going to add a positive 12 here. So we got y equals negative 3, x squared plus 4x plus 4. It's going to be x plus 2 squared. 12 minus 8 is 4. Okay, so here's my answer in Vertex form over there. All right, guys. Again, guys, do make sure do not fall behind in your textbook questions in this section. Okay, it's just that you guys need a lot of practice on these guys so you can get good at these ones. And we're going to move on to we're going to continue completing the square in the next lesson, but they're going to be with more word problems that we need to understand as well. All right, see you in the next video.